So this is a triangles review, and triangles are very heavily tested on the ACT. It's definitely the most commonly tested shape. So there's a lot of things you need to remember, facts and formulas and such. So let's start with the fact that there's 180 degrees in a triangle. That probably is not shocking, but um, on a question like this one, you are going to be using that information to solve it. So the question says that A, D, B, and G are collinear, and that's kind of a funny term that all it means is that they're on the same line. It's just a fancy word for saying the same thing. And really, for your purposes, it appears that they're on the same line, and so they are. So, at any rate, CAD measures 76 degrees. That'll be right here. BCD measures 47. That one's right here. CBG is 140. That's going to be the outside here. And we're supposed to find this one. And really marking everything is helpful. That way you can keep track of it all. So here, this angle will be 40 degrees because a straight line has 180 degrees and the angle on the outside is 140, so this remaining angle on the inside will be 40. That means that this angle, angle CDB, is going to be what is remaining with that triangle CDB. So it'll be 180 minus 40 minus 47, which is, I believe, 93. Okay. And then because of that information, this angle will be 87. Again, because there's 180 degrees in a straight line. And then you can figure out our question mark angle by subtracting from 180, subtract 76 and subtract 87, and what is left over is 17 degrees, and that is our answer. Okay. Here's another angles question. This one uses a little bit of different information. So when you have intersecting lines, the opposite angles are equal. So that means that this angle and this angle are going to be equal. And this one will be 40 because with this triangle ABC, you already have the other two angles, 80 and 60, so what remains is going to be 40. That means this will also be 40. If you subtract 110 and 40 from 180, you'll get 30, which is our angle E here, and that is our answer. Okay. This one, they're asking you to find the area of the triangle, and so the formula is 1/2 base times height. Be sure you remember that. And with this particular question, they actually give us the area and the base. You're told that this side XC is 8. And we're just trying to find the height. So substitute 32 in for the area. 1/2 the base, which is 8, times height. So that'll be 32 equals 4 times the height. Divide both sides by 4. That's going to leave you with 8 equals the height. That's our answer. Okay. Below here, this one is on an isosceles triangle. And isosceles just means there are two equal sides and two equal angles. I don't know why that did that. That's a little weird. Okay, two equal angles. And those equal angles will be opposite the two equal sides. So to answer this particular question, they don't give you a diagram, so your first step is always to draw one. And X, Y, and XZ, this little symbol, which I realize is a little blurry, is a congruent sign. And that just means that essentially they're equal. So X, Y, and XZ are going to be the two equal sides of this triangle. Let's label these points. So XY is equal to XZ. That means that angle Y and angle Z are also going to be equal. They tell us Y is 34, so Z is also 34. So our remaining angle, angle X, will be 180 minus 68, which is going to be 112. That's our answer. All right. Moving on. This one has to do with an equilateral triangle. And this particular question, I brought this up because there is an element of equilateral triangles that when they're tested, this tends to be part of it. So an equilateral triangle has equal sides and equal angles. So all of the angles are going to be 60. Okay. And if you drop a vertical down from that point at the top, you're going to create two congruent triangles, and this hits the base at the midpoint. Okay. With this particular question, they tell us that we have an equilateral triangle with the coordinates of the two vertices labeled. So they're telling us that the length of this base, that's going to be the x coordinate, so you'll subtract 0 from 2m, so the length of the base is 2m. So that means the other two sides are 2m also. Okay. We're trying to find the coordinates of the third vertex. So when I mentioned a moment ago that if you drop a vertical down here, you cut the base in half. So the x coordinate of that point is going to be half of the base because it's at the midpoint. So half of 2m is just m, which means the x coordinate is going to be m. So we can rule out a, we can rule out d, and we can rule out e. Okay. The next step here, and I'll talk a little bit more about these in just a minute, you can use the special triangle rule to determine the length of the vertical. That has to do with a 30, 60, 90 triangle, because if you drop a vertical, this angle is 60, and this angle would be half of that 60-degree angle, so it's 30, and that's what you end up with. However, you can still use the Pythagorean theorem, which will definitely work. You have the length of the short side down here is m. Remember, that was half of the base. So that'll be m squared plus x squared. We'll just say x is the height of the vertical. And that's going to be equal to 2m squared. So m squared plus x squared equals 4m squared. Oops, not x squared. 4m squared. If you move the 4m squared to the other side, subtract from both sides, you'll have minus 3m squared. And then move the x squared to the other side, so that's negative x squared. 3m squared equals x squared. We'll just get rid of the negative signs. And x is going to be the square root of 3m squared. And even if you're not completely sure at this stage how to simplify that radical, you can probably surmise that the right answer is going to be C because there's a square root of 3 in there. But you'll take the m out from underneath the radical, which would just be m times root 3 equals x. So the answer is C. Okay. But there is a rule about that. We'll get to it in a minute. Okay. The next one is just a straight Pythagorean theorem question. So I know I used it on the last one, but we'll review it again anyway. Pythagorean theorem is a squared plus b squared equals c squared. You can only use this on a right triangle. So if you do not know that your triangle is a right one, you cannot use the Pythagorean theorem. But the pieces in that formula are a and b are the two legs of the triangle, and c is the hypotenuse, which is the length of the side opposite the 90-degree angle. So here we have the two legs, and we're just supposed to find the hypotenuse. So that'll be 1 squared plus 2 squared equals c squared. So that's going to be 1 plus 4 equals c squared. 5 equals c squared. square root of 5 equals C. So G is our answer. Okay. This one is kind of a shortcut, and if you can remember these, it can often save you some work. Not 100% necessary, but not Pythagorean theorem. Oh, Pythagorean triple. Okay. So a Pythagorean triple is a triangle where all the sides are integers, and they appear pretty frequently on the test, and if you are able to recognize them, you can answer questions almost immediately without having to do any work. The most common one is a 3, 4, 5, where we've got this side is 3, this side is 4, this side is 5. You may also see multiples of that 3, 4, 5, where it's a 6, 8, 10 maybe, or a 9, 12, 15. This particular question, you can see that one of the legs is 3, the hypotenuse is 5. So if you know your Pythagorean triples, you will know immediately that the other side is 4, and you don't even have to do any work. Pretty easy. There is another Pythagorean triple, not as common as the 3, 4, 5, but it's worth bringing up anyway. This one is a 5, 12, 13, where the short leg is 5, long leg is 12, hypotenuse is 13. Okay. This question, even though they don't give you a diagram, as long as you draw the triangle correctly, you'll see that this is one of these. So it says a boat leaves the dock and sails directly north for 5 miles, so we'll draw it right there. This is 5. Then it turns and sails 12 miles east, so that's going to be this side, which is 12. And they're asking you how many miles is the boat from the dock, so that's this distance, and you've just created a right triangle there. So the two legs are 5 and 12, and you know the hypotenuse is 13, straight off. Okay, so that's easy. Now we're going to get into some special triangle rules. And these are trigonometry concepts that are just shortcuts for solving for the sides of triangles if you know certain information about the angles of those triangles. Sometimes these will just save you some work, and sometimes you have to know them or you're not going to be able to answer the question. So this one is an isosceles right triangle, which you could also call a 45, 45, 90 triangle, where of course you have a 90-degree angle, and then the two other angles are going to be 45 just because they are equal, and they have to be. So for an isosceles right triangle, there is a rule where if the length of the leg is x, so and both of the legs would be equal, of course, the length of the hypotenuse is going to be whatever x is times the square root of 2. So here, since you know that this is an isosceles right triangle, you know that one of the legs is 10, you will also find that the hypotenuse is 10 root 2, so that's our answer. In this case, you can use the Pythagorean theorem also, but it's not necessary, and obviously this is way faster. A very common way you will see this tested, I'm just going to draw this, is if you have a square and they're asking you about the length of the diagonal. The diagonal of a square creates a 45, 45, 90. So the hypotenuse will be the length of the side of the square times root 2. Okay, so that's easy. The other one, the other special triangle that you need to know is a 30, 60, 90. Okay, so if I draw one like this, okay, the short leg is the one opposite the 30-degree angle, which in this case we'll just label it x. The length of the long leg, which would be the one across from the 60-degree angle, will be x root 3. The hypotenuse will be 2x. Okay, so I alluded to that a little bit with that earlier question about the equilateral triangle, and that's just one of the really common ways that you'll see this tested. If this is an equilateral triangle, you know this angle is 60 and this angle is 60. If you drop a vertical down the middle of the triangle, you create two 30, 60, 90 right triangles, okay, where this would be the short leg, this would be the long leg, so that's going to be x root 3, the vertical here. the hypotenuse would be 2x. Okay. So on this particular question, though, they give you the length of the hypotenuse and they give you two of the angles, so you can confirm that this is 30 because you've got a right angle and 60, and so the remaining degrees has to be 30. The length of the short leg will be half the hypotenuse, so it's going to be 10. And the length of the long leg would be 10 root 3. So the answer is C. Okay. Next, let's talk about similar triangles. And similar triangles are really heavily tested. And you always want to be looking for ratios to compare those two triangles. So the definition of a similar triangle is that they have equal angles. Similar triangles have equal angles. And because of that, the lengths of the sides are proportional. Lengths of sides are proportional. Okay, so with this one, because of the way they have this oriented, I think it's easier to redraw the triangles so that you can match up the sides, because if you have the sides different, you're going to get in trouble. D, B, and A. Okay, this is the 30 degree. This is the right angle. This is the 60 degree angle. If you flip triangle ABC on its side, C is the 60 degree angle, B is the right angle, and A is the 30 degree angle. Okay. So you just want to find the similar side. So and the question's asking the ratio of the perimeters of the two triangles to each other. You just want to find which sides are equivalent also. Okay. So AB and AD, if you look at these two triangles, so AB here, AD here, are the equivalent sides, and that is answer choice F. But just to be sure, you want to look at all of the other answer choices as well. AB is not equivalent to BD because that would be this side equivalent to the hypotenuse of that one, which is not true. So you know that one is wrong. AD and AB. So AB again, or no. AD and BD. Those are actually both on the same triangle, so that doesn't work. BC and AD. So BC and AD, that would be this side compared to this one, which that doesn't work. And BC to AD would be this side, or BC to BD would be this side to the hypotenuse, which again does not work. So our answer is F. Okay. One more similar triangles. And I just wanted to show this one because this comes up a lot. When you have these overlapping triangles like this, they are going to be similar because they share an angle here. You have two right angles, and so this angle and this angle are also going to be equal. To do this one's a slightly more complicated, but not too bad maybe. I always like redrawing the triangles because having them overlapping is just kind of hard. So this is going to be the larger one. The length of this side would be 2640 plus the question mark. The smaller one, this side is 1200, and this side is the question mark. So you'll set up a proportion to solve. So the short leg, you'll put those both on top so they're corresponding to each other. Over the long leg, over the question mark, and then you can just cross multiply and solve. So that'll be 2000 times the question mark equals 1200 times 2640 plus the question mark. And definitely need a calculator here. So 1200 times 2640 is 3,168,000. That's a big number. Plus 1200 question mark. And then we still have 2000 question mark here. Subtract 1200 question mark from both, so that'll be 800 question mark equals this 3,168,000. Divide both sides by 800 and you are left with, the question mark is 3960, which is H. You can always eliminate some answer choices too, just because they don't tell you that this drawing is not drawn to scale, so you can assume that it probably is. F doesn't make any sense because CD clearly looks to be longer than BC, so you can rule that one out. And 5840 would be more than twice BC. So that one looks like it's way too big. So just based on those things, you can narrow it down a little bit, even if you're not sure where exactly to go. So that's your triangles review. I hope that helps, and good luck with the test.